All right, so I believe we're moving on with Cargo. And today's topic is Cargo Workspaces, which is, this is chapter 14, section 3. Let's get it. Close this. Cargo Workspaces. In chapter 12, we built a package that included a binary crate and a library crate. As your package develops, you might find that the library crate continues to get bigger and you want to split up your package further into multiple library crates. In this situation, Cargo offers a feature called Workspaces that can help manage multiple related packages that are developed in tandem. Okay. Yeah, so what they're saying here is that we're going to go over workspaces, and the purpose of workspaces is to, let's say you have a library crate and the code is just getting really large. You don't want to maintain everything in that one package. Maybe you want to break it up into smaller packages, and that's what workspaces facilitates. Seemingly, we're about to find out. Creating a workspace. A workspace is a set of packages that share the same cargo lock and output directory. Let's make a project using a workspace. I think I have a terminal. Let's do it there today. There we go. Clear, so you don't have to see all of that. We'll use trivial code so we can concentrate on the structure of the workspace. There are multiple ways to structure a workspace. We're going to show one common way. We'll have a workspace containing a binary and two libraries. The binary, which will provide the main functionality, will depend on the two libraries. One library will provide an add one function, and a second library an add two function. These three crates will be part of the same workspace. We'll start by creating a new directory for the workspace. Okay, let's just follow the instructions. Do what they say and see, hopefully it works out. Create a new directory for this workspace. We are in it, and essentially what they said here is that we're going to be creating a main crate that's going to have a binary and a library, and then we're also creating another library, a second library for the add to function. Next, in the add directory, we create the cargo.toml file that will configure the entire workspace. This file won't have a package section or the metadata we've seen in the other cargo.toml files. Instead, it will start with a workspace section that will allow us to add members to the workspace by specifying the path to our binary crate. In this case, the path is adder. Okay. So what they said here is, let me create a cargo.toml file. And then they want me to do stuff to it. Create a workspace. Oh, I have cap locks on. Yeah, it's all lowercase. Workspace. Members. Adder. Okay, save that and exit. So I did what they told me. Created a toml file, put this workspace, have members. The only member in it currently is adder. Next, we'll create the adder binary crate by running cargo new within the add directory. I see. Okay. So we're creating a cargo crate within this directory. New adder. And that's right there. At this point, we built the workspace by running cargo build. The files in your add directory should look like this. And it does not look like that. Mainly because I haven't done a cargo build yet, so I don't have a lock file. But let's do that. Cargo build. And now I do it. I see my lock file, and I have my target, and I have my adder. And then my adder Let's just confirm what that looks like. Has the cargo.toml file and the source, and in source there's main because that's what's created. Okay, so now it looks exactly like what they have there. Cool. The workspace has one target directory at the top level for the compiled artifacts to be placed into. The adder crate doesn't have its own target directory. Even if we were to run cargo build from inside the adder directory, the compiled artifacts would still end up in add/target rather than add/adder/target. Cargo structures the target directory in a workspace like this because the crates in a workspace are meant to depend on each other. If each crate had its own target directory, each crate would have to recompile each of the other crates in the workspace to have the artifacts in its own target directory. By sharing one target directory, the crates can avoid unnecessary rebuilding. Okay, that was a mouthful. So coming back to here, what they're stating initially, and you can see it in this diagram, is that there's only one target directory for all of the crates within this workspace. Currently there's only adder, but if you note, adder does not have a target directory. So when we compile, even if we compile something for adder, it's going to end up here. So the reason why they do this is because, one, all the crates in the workspace is supposed to be dependent on each other. And if they are dependent on each other, then you can't build them independently because, well, they might share code. Because if you were to build them independently, then you have to recompile all of the individual parts, or all of the individual crates within this workspace for each crate within it, so it can use all the other stuff that exists. We don't want to do that, so they only have one build, one target, and everything shares stuff. Creating the second crate in the workspace. Next, let's create another member crate in the workspace and call it add1. Change the top level cargo.toml file to specify the add1 path in the members list. Okay, so now it looks like we're adding another member to this workspace. So make sure we're in the top level. I see it. Nano cargo.toml file. And here we're just adding one more person. We call it add-1. Okay, and then we're creating this. Then generate a new library crate named add1, and this is going to be a library crate. Got you. Cargo new add-1 lib. So as you see here we go. We created a new crate, and they have our directory structure, which should look like this. We already confirmed the adder stuff. Now we just have to look at the add1, which is a library crate. Add1, and so it gets moved up. Here's the add1. There's the source, and yeah, you can, by tree, you can see the source only has a lib in it. We're good. In the add1/source/lib.rs file, let's add an add1 function. And then here's the code that they want us to add. And it's a simple function. X I32, return I32, just add 1 to something. Yeah, we don't need. We can just do that in Nano real quick. Source, it's there. Nano. Make a public function. Add 1. X I32. I32 x plus 1, and just to make sure it works, we can do a cargo build. It finished. Cool. Now that we have a library crate in the workspace, we can have the binary crate adder depend on the library crate add1. First, we need to add a path dependency on add1 to adder/cargo.toml. Okay? So here is stating now that we have in our workspace, we have a crate that our main crate is going to depend on. We have to explicitly write the dependency in the cargo file, which makes sense. So let's go up back to the top level directory, nano cargo.toml, and we're making a dependency dependencies. Hopefully I spelled that right. Space add -1 is equal to path Oh, it's a relative path from adder. I see. Okay. I guess that could imply that our workspace can only have one main binary. I mean, you can always have a cargo libs and then have other binaries there, but meh, I don't know. Continuing onward, let's do a cargo build just to make sure everything's kosher. Unused manifest key dependencies. So it looks like I have a warning because my dependencies that were listed are not being used. But outside of that, it seems everything's good. Everything seems good. Cargo doesn't assume that crates in a workspace will depend on each other. So we need to be explicit about the dependency relationship between the crates. That makes sense. That could explain why I have a warning here. It did not assume that the crate that was listed in my dependencies is being used. Next, let's use the add1 function from the add1 crate in the adder crate. Open the adder/source/main.rs file and add a use line at the top to bring the new add1 crate into scope. Then change the main function and call the add1 function as in listing 14-7. That makes sense. So what we're doing here seemingly is we're going to adder source main.rs, which is our binary file, seemingly our main binary file, and we're going to explicitly use the function that we just created, the add1 function, in the add1 crate, and we're using that in our adder repo, I guess Cargo Workspace, so we can explicitly use that dependency. And then the code seems pretty simple. We should be able to build it right after just to make sure everything works. And that's what they did here. So let's do that. Go to adder source main, and we have a use add1, and then in our main, hopefully this is easy to read. I'm not sure. It's my first time using Nano in a video, but I like Nano. Number equal 10. Print line. Hello world. That number plus 1 is this number. And then we pass num and add1. Is it add1? Is that what they have here? Add1. Add1. Num. Yeah, Nano does that sometimes when you click around. And I don't think I put a ending curly on that. So let's save, yes. And then we see we do a cargo build from anywhere. Use add one. No add one external crate. Oh, that's not what I was expecting. Use add one. Use add one. Did I put the dependency in the wrong location? Adder that cargo. Oh. Alright, that was a big hubbub to do about nothing, because I'm pretty sure I put the dependency in the wrong file. Ouch. So let's take it out of this file. And go to adder, which actually uses it, and put in that file. Dependencies. Add one equal, and that's why I had the route going up. That makes sense now. I'm gonna have to reshoot that for a bit, and then I can do a cargo build, and now everything works fine. Ah, I see. So the error I made was when writing this, I didn't pay attention to the file it was going in. I put it in the top level directory. No. This add one is the dependency of adder, and thus it should be in the adder.cargo.toml file. Once I place it in there, did cargo build, everything works as it should. So we're now here. To run the binary crate from the add directory, we need to specify which package in the workspace we want to use by using the -p argument and the package name with cargo run. Okay, so if we want to run this code, we have to be in the top level directory. I don't think we do, but let's do it from here. Cargo run -p adder. It ran. Can I run it from adder? I can run it from adder. Can I run it from add one? Let's check that out. Ooh, I can run this from anywhere within any of the workspaces, and it does the same thing. That's kind of cool. Okay. This runs the code adder/source/main.rs, which depends on the add one crate. Depending on an external crate in a workspace. Notice that the workspace has only one crate.lock file at the top level of the workspace, rather than having a cargo lock in each crates directory. This ensures that all crates are using the same version of all dependencies. If we add the ran crate to the adder/cargo.toml file and add one/cargo.toml files, Cargo will resolve both of those to one version of ran and record that in the cargo.lock. Making all the crates in the workspace use the same dependencies means the crates in the workspace will always be compatible with each other. Let's add the ran crate to the dependency section in the add one cargo.toml file to be able to use the ran crate in the add one crate. Alright, so that makes sense. So earlier we noticed how there's only one cargo.lock file, right? And that's at the top level directory. I can show you again here. Tree. Ooh, there's a lot of things there. Let's just do ls. So right here we have the cargo.lock file. However, if we go to adder, we notice that there is no cargo.lock file, but there is a cargo.toml file. And in cargo.toml files, you can specify your dependencies. Well, so if you have multiple crates in your workspace and they all have dependencies, they don't have to necessarily have the same dependencies. So it makes sense for each workspace to define their own dependencies. However, in terms of the versions for these dependencies and where the resolutions of which ones you're going to use are going to be located, that should definitely be in your top level directory. Because if it is there, you can ensure that all of the crates within your workspace are compatible with each other. As in, one workspace is not going to use, let's say, they brought up RAN crate, RAN version 1, and the other one's going to depend on RAN version 2. So that'll be a dependency conflict, and we wouldn't want that. So in order to avoid that dependency conflict, we have one cargo.lock file, and that's in the root of the workspace. The root of the top level directory that governs all of the workspaces. And now let's add that dependency. We're doing it to add one. I'm making sure I'm going to the right place now. Add one. Nano. Cargo.toml. And we're making one dependency. And it's version 0.3.14. So if we do a cargo build from here, I don't think it matters where we do it. We should notice that the RAN is going to be in our cargo.lock file, like that version. So the build ran successfully. Let's go back to the top level directory. And I never really look at cargo lock file, so I don't know what this is going to look like. We have a couple things. Ooh. Okay, let's make that bigger for a second. Well, not necessarily that big. Here we go. We have add one, which is our dependency. We created this crate and they gave us a version for it. And that depends on RAN, which has the registry link. We have adder, which is the main one, which depends on add one, which is at that version, which is within this thing. And then we have some other dependencies, probably of RAN, but libc might not be. Actually, no, probably. And then we have our RAN version, RAN core. Oh, this is very interesting because you can see all the packages that RAN depends on, and most of them are not at the version numbers that we just specified. Like if we move this to the side real quick, we specified 3.14. I see RAN core at 3.1, RAN core at 4.2, RD RAN at 4.0, but I'm not seeing any 3.14s. Maybe that was all the way at the top. I don't know. This is really awkward. I see the versions explicitly written here, and I'm not seeing 3.14. Let me do a search real quick. This is bugging me. This is less. 3.14. Not found. 3.14 is not in this file. I am not sure what that means, but that's kind of scary. Let's not think about that for now. So yeah, we built the RAN, created, downloaded its dependencies. We're good there. That's here. And even here, it mentioned what version it was compiling, and it wasn't 3.14. That's kind of crazy. But moving on. The top level cargo.lock now contains information about the dependency of add one on RAN. However, even though RAN is used somewhere in the workspace, we can't use it in other crates in the workspace unless we add RAN to their cargo.toml files as well. For example, if we add use RAN to the adder/source/main rs file for the adder crate, we'll get an error. Which makes sense because, basically what they're stating here is that even though one of the crates in the workspace, one workspace, said we need RAN as a dependency, because the other ones didn't explicitly state that they also need that dependency, they can't use it, regardless if it's available. That makes sense. They shouldn't be using it. To fix this, Edit the cargo.toml file for the adder crate and indicate that ran is a dependency for that crate as well. Building the adder crate will add ran to the list of dependencies for adder in cargo.lock, but no additional copies of ran will be downloaded. Cargo has ensured that every crate in the workspace using the ran crate will be using the same version. Using the same version of ran across the workspaces saves space because we won't have multiple copies, and ensures that the crates in the workspace will be compatible with each other. So yeah, they're just restating what we were stating earlier about how workspaces and dependencies work. They also said to fix this error, which I didn't write this error, so we don't have it over here. But if adder wants to use ran, they have to explicitly put it in the cargo.toml file. And once it is in there, Cargo will ensure that via the top level lock file, that all of the workspaces are using the same version of ran, the ran crate. As such, you only have one download of it, so you're not wasting all that space with multiple versions of the same package. Adding a test to a workspace. Oh, this is interesting. For another enhancement, let's add a test of the add one function within the add one crate. That's a lot of add ones. Okay. So now we're going to add a test, which I think already came with a test, but I think it comes with a test when you automatically create. So I should be able to do cargo test now. And one test did run. Let's please them. Let's go to where they want me to go and add the code they want me to add. Nano source lib. Alright, so we open the file. There's already a test in here, and seemingly they took the function name. So they just want me to change this test to that test. Okay, I can do that. We're changing assert. No, assert equals stays assert equals. We're changing this to 3, and we're using the add one function explicitly. Add 1 to 2, and one thing we haven't done is import. So use super, so we have access to everything in the crate above us, because this is module. This is a module which kind of segregates things. So we need to go up 1, which is super, and then import everything in that upper scope, I guess you can say, into this one. And we do that with the star. And that should work. Cargo test. Yeah, it works. It passed. Same documentation as before. Same output as before. Now run cargo test in the top level add directory. I'm not in that directory, so I can do that now. And it ran as it should. So yeah, we covered this earlier when we were messing around with cargo and running commands in different workspaces. Regardless of which workspace you're in, cargo will seemingly work. However, it is probably good practice to go to the top level directory. I mean, typically if you want to run stuff, it's a habit that's built in other languages. You seemingly don't have to follow it here, but I guess it's a good idea. It might not be. The first section of the output shows that the it works test in the add one crate passed. The next section shows that 0 tests were found in the adder crate, and that the last section shows 0 documentation tests found in the add one crate. Running cargo tests in a workspace structured like this one will run the test for all of the crates in the workspace. Okay. Let's verify some of that, because there's not much here. But let's look at theirs first to make sure everything's the same. Add one debug. This is the adder. Oh, that's the -p flag. We don't want to look at that output. We want to look at this output. Add one cargo test, doc test, add one. So I'm seeing add one, but I don't think the order is the same. No, wait, running add one. Here it is. Found it. Here's the hash. Running test, it works. Filtered out. Running test for adder. Running test, 0 test run. And then here's the doc test. And nothing was filtered out. So this output is kind of hard to parse if you're not used to looking at it. But the information is there. Okay. We can also run tests for the one particular crate in a workspace from the top level directory by using the -p flag and specifying the name of the crate we want to test. So let's just do add one. See what that looks like. And that is shorter in terms of output. And we have the it works. Yeah. Okay. Let's just add one. Makes sense. This output shows cargo test only ran the test for the add one crate and didn't run the adder crate test. If you publish the crates in the workspace to crates.io, each crate in the workspace will need to be published separately. The cargo publish command does not have a --all flag or a -p flag, so you must change to each crate's directory and run cargo publish on each crate in the workspace to publish the crates. Okay. So what they're saying here is that when you go to publish a crate that has workspaces, you can't publish them all at once. And because they're individual crates, it kind of makes sense that they should be published individually because they're like libraries that can depend on each other. But that being said, you have to go to each directory or each workspace itself and then go through the cargo publish process. Understood. For additional practice, add an add two crate to the workspace in a similar way as the add one crate. I'm going to skip over that. As your project grows, consider using a workspace. It's easier to understand smaller individual components than one big blob of code. Furthermore, keeping the crates in a workspace can make coordination between them easier if they are often changed at the same time. I see. So what they're saying here is that just in general, as a good practice, you never want to have like large blocks of code. You kind of want to break things up into smaller components that are easier to digest. And when you're doing that, one way to accomplish that is to do it via workspaces. So they're advocating the use of workspaces, especially as your project grows. Another point they made is that if like small pieces of code keep changing within your project, like as it grows, it organically has to change because the way you think about things change, and maybe the way you wrote it the first time isn't the best solution. If things are constantly changing, then it's easier to have them change in a workspace because it's, I guess, easier to find, easier to identify that one block of code. Just human parsing. This all this is. Human parsing and how to optimize it. With that being said, that is the end of the video. I hope you liked it. I kind of struggled a little bit just because I put things in the wrong directory. But outside of that, I think everything went pretty okay. I learned something. Hope you learned something. If you'd like to subscribe, outside of that, peace.